Ever drive past those massive, graceful giants on the horizon and just wonder, how in the world do those things work? Well, in this explainer, we're going to break down the science behind the modern wind turbine. Let's get right into it.
So first, let's just talk about the sheer potential here. Every single day, the wind whipping around our planet generates enough raw energy to produce 35 times more electricity than all of humanity uses. Just think about that for a second. It's an absolutely incredible, almost completely untapped reservoir of power just waiting for us. So, that's the big question, right? How do we possibly harness all that incredible, free-flowing energy? How do we turn the wind into something that can power our lives? The answer, of course, is the modern wind turbine. Okay, so for our first section, let's cover the fundamental process. We're talking about going from the simple movement of air to the electricity that's literally powering your screen right now. It all kicks off with a really old idea that's been given a serious high-tech upgrade. The basic idea really hasn't changed all that much. The blades catch the wind and that creates rotational energy. For centuries, old-school windmills used that rotation for tough mechanical jobs like grinding grain or pumping water. The huge difference today, the real game changer, is the end goal. We want to convert that same spinning motion into electricity.
So it all boils down to this really simple three-step energy conversion. First, the blades grab the wind's kinetic energy. That's just the energy of motion. Second, this turns a rotor, creating rotational energy. And finally, that rotation spins a generator, which spits out electrical energy, from wind to watts. It sounds simple, but it's incredibly powerful.
All right, let's zoom in on the heart of the machine. Section 2 is all about the blades themselves. Their design is absolutely the key to squeezing out maximum efficiency, and believe me, there's a ton of clever engineering packed into every single one. So if you want to get the most power you possibly can from a turbine, it really comes down to three main things: the blade's size and how it's oriented, its aerodynamic design, and of course, sticking it in a place that has a whole lot of good, consistent wind. Now, the orientation part is really interesting. You've got your vertical axis turbines, which are kind of cool because they can catch wind from any direction, but their big downside is they're just not very efficient. And that's exactly why the horizontal axis design, the one we all recognize, is totally dominant. It's way more efficient, but it's got one little catch. It always needs to be facing directly into the wind.
And that's where this cool term yawing comes into play. We're not talking about some old-school weather vane here. Modern turbines use all these sophisticated sensors and computer systems to automatically turn, or yaw, to make sure those blades are perfectly positioned to capture as much energy as possible every single second of the day.
And here's the secret sauce of aerodynamics. See, modern blades aren't just flat planks. They're shaped just like airplane wings. As wind flows over that curved top surface, it has to speed up, and that creates a pocket of low pressure. That pressure difference generates lift, which actually pulls the blade forward. It's the exact same physics that gets a giant airplane off the ground. Pretty cool, right? And these blades are just marvels of engineering. They're built from layers of fiberglass and resin, which makes them unbelievably strong. They've also got this subtle twist from the base to the tip. Why? Well, the tips of the blades travel way faster than the part near the hub. This twist makes sure the entire blade hits the wind at the perfect angle, maximizing energy capture along its whole length. It lets them stand up to everything from scorching sun to lightning storms for over 20 years. Finally, let's talk location. And in this case, height is everything. To get up and out of all the choppy, slower air near the ground, most turbines stand well over 100 meters tall. Way up there, the winds are way stronger and much more consistent, and that means more power. Okay, so we know how they work, but what's the actual real-world impact? This next part really puts the power of these machines into perspective. Let's talk scale. So get this. A single, large, modern onshore turbine, the kind you might see driving through the countryside, can generate enough electricity in 1 year to power about 750 American homes. I mean, that's an entire neighborhood powered by just one machine. But it doesn't stop there. When you start grouping them together into a wind farm, say, with about 200 turbines, the numbers just get staggering. A farm that size could power over 150,000 American homes for a whole year. The scale is just immense. And then you go offshore. The largest offshore turbines are true giants. I mean, the biggest one operating right now has blades that span 220 meters. Just one of these can power 16,000 European households for a year. A single turbine powering a small town. Wow. Now, as promising as all this sounds, it's really important to have a balanced view. Wind energy isn't a perfect magic bullet. It has its own hurdles, and our final section is going to look at the challenges we still need to figure out. First off, there's a hard limit set by physics itself. About a century ago, a physicist named Albert Betz figured out that a turbine can never capture 100% of the wind's energy, because if it did, the air would just pile up behind the blades and stop. This limit, which we now call Betz's law, is 59.3%. We can get close, but we can never, ever break that fundamental rule. And beyond physics, you've got the practical challenges. Some people really don't like how the turbines look on a natural landscape. And then there's the biggest issue of all, intermittency. The wind just doesn't blow all the time. Figuring out how to plug this fluctuating power source into our steady electrical grids is a major, major engineering puzzle. But even with all those challenges, the bottom line is pretty clear. Thanks to decades of innovation, modern wind turbines have made wind energy the most efficient and the cheapest source of new electricity available today. It's already a huge piece of our global energy puzzle. Which leaves us with one final thought. As technology just keeps getting better and better, with turbine design, with energy storage, with managing the grid, you have to ask, just how far can we push this thing? Could the immense renewable power of the wind actually blow away our energy problems for good?